Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshop and exercises to learn about AWS services. These workshop and exercises are published on our website aws-dojo.com. Today, I'm going to talk about AWS IoT services. So let's get started. So what exactly is AWS IoT services? So when you are trying to build, when you have a scenario where you are ingesting data from your IoT devices, and then you want to run different types of analytics on top of that, whether you want to do reporting or dashboarding, or you want to do some kind of interactive analysis in a Jupyter Notebook type of interface, or you want to do some kind of big data analytics or machine learning using containerized images. When you're trying to build this kind of pipeline where you bring your data and then consume your data in reports, in machine learning, in interactive analytics, then such a configuration you can achieve using AWS IoT Analytics, which is a managed service from AWS Services. So this looks like a very big box to me. I mean, AWS IoT Analytics, okay, fine, you take the data in and then then we can simply do reporting or analytics on top of that. But what exactly works under the hood? So let's go a step further. So if you go a step further, AWS IoT Analytics has got 4 components which you have to configure. You have to configure channel, pipeline, data store, and data set. And each of these components have got different purpose. So for instance, your channel is used to store your raw data. Okay, your pipeline is used to perform transformation on the raw data, and your transformation could be you want to clean the data, or you want to add a new attribute, or you want to do some attribute calculation. Such things you can do in the pipeline transformation. Then your data store is used to store the process data, the transformed data from the pipeline that is stored into your data store. And finally, data has to be consumed, and for that you create different types of data set using queries, and then those data sets are then available for consumption, whether you want to do any kind of automated machine learning or big analytics, or you want to do any kind of reporting or dashboarding. So these are 4 different components which you have to configure in AWS IoT Analytics to create this pipeline which automates and operationalize your analytics on your IoT data. So if you go a step further, in AWS IoT Analytics, from a channel which stores the raw data, you can actually configure multiple pipelines. So if you think that you want to perform different types of transformation, you can create more than one pipeline on the same channel to do different types of configuration. Now, destination of the pipeline is data store, and each pipeline can have their own data store, or if you want more than one pipeline to store data, to have one data store, that is also possible. So pipeline can decide their own data store. That could be one of their own data store, or could be one of the shared data store. And once your data is in the data store, this is the process data, this is transformed data, this is ready for consumption, and such data is then consumed for reporting or analytics by creating different small data sets. Okay, so you can use query in the data set to create different type of data sets, and then those data sets are then used by the consumer. And why we have this data set over here? I mean, your data set could be as simple as select everything from the data store, but it's kind of creating an abstraction here. So what we're saying here is that in a simple form, you can have a single data set saying, hey, give me everything from the data store. But if different people want to perform different types of analytics or reporting on this data, then they can have their own data set and they can simply work with their own data set. Okay, and for that purpose, this abstraction has been built where the consumer can create its own data set and can use it for its own analytics or reporting purposes. So what I'm going to do now, I'm going to talk about each of these components in detail to discuss how they work and what configuration need to perform. So starting with the channel. Channel is where data is published. Channel stores your raw data, and this raw data is immutable. It is not changed. So anytime you want to work with raw data, you simply come to the channel and you can get the raw data. This raw data is stored in the S3 bucket, and this S3 bucket could be AWS managed bucket, or it could be a bucket which is provided by the customer. Okay. Now, in how many ways I can publish data to the channel? One way to publish is that you can use this batch put method, and this batch put method is a method which is available in AWS IoT Analytics API, and this is how the request format look like. You need to provide the channel name, message ID, and your payload, your message, and this message will be published to your channel. This is one way of working. The other way of working, and that is more popular, is using MQTT public subscribe model, where a device will publish an MQTT message to the topic, and then you will have an IoT rule which will simply looking into this topic, and when the message get published, it will route that message to the channel. That also you can configure, and this is the more popular way. Now, if you don't understand how MQTT PubSub model work, you can look into other video I think I have 2 videos where I talk about how this PubSub model work and how MQTT messaging work. But in most of the cases, since you're using IoT analytics with IoT devices, your devices use certificate-based authentication and MQTT messaging, MQTT messages to publish the message. And in that case, you can use IoT rule to simply route the message to the channel. And this is the example of how the IoT rule look like. It's looking into an IoT, IoT topic and then simply routing that message to the channel. So 2 methods to publish data to the channel. So having talked about the channel, let's talk about the pipeline. And pipeline is responsible for performing the data transformation. So basically it takes message from the channel, it takes the raw message from the channel and performs different types of transformation. You can have more than one pipeline running on the same channel if you want to perform different types of transformation. And what pipeline does that when it has transformed the data, it will simply store the data or message into your data store. Now, in pipeline, you can configure multiple things. One of the things is that in pipeline, you can define the schema or attributes you are looking for from the raw message. So when the pipeline takes the raw message, you have a choice to define what attributes could be present into your raw message. And these attributes you can define either manually or you can also upload a JSON document to define that. So this is how it looks like. You can define what attributes you are expecting and what their data types are in the raw message. It really helps pipeline to understand the schema of the message coming and then use that for the processing purposes. Now, once you have defined the schema, you define different types of transformation activities. And activities could be, you might want to remove some attribute, add some attribute, create some calculated attribute. If you have very complex business logic, you might want to use a Lambda function to transform it. You can filter some messages. And very interestingly, actually, you can append your device registry information. So when you register your devices, you provide device group and other device attributes. That information can be appended to the message. And you can also append device shadow information, device state information. If you don't understand what device shadow is, look for my video about device shadow where I explain what device shadow is and how it and what is the importance of device shadow in the IoT world. But yeah, and these are some predefined transformations you can use within the pipeline to transform your message into a processed message. And again, you have a choice to select one or more such activity to perform different types of transformation. So having talked about the pipeline, let's talk about the data store. Data store is pretty simple. It stores your processed data. So it is a destination for your pipeline. So when the pipeline has completed the transformation, it will write data into the processed data store. More than one pipeline can have the same data store, and data store stores data in Amazon S3 bucket, which could be a customer managed bucket or could be an AWS managed bucket. Now, one more property which is very important for data store is you have to select in what format you are going to store your data. And that could be either JSON or Parquet format. And once you define a data store format, you cannot change it. But when you're configuring a data store, you can decide the format of the data store, and your data store will simply store your message in that format. So having talked about the data store, now let's talk about data set. And data set is the layer which is used for consumption. So AWS IoT Analytics does not allow your consumers to directly hit the data store. It says that talk to data set. And data set in simple terms could be everything from data store, or you can create a small subset of data from your data store. So depending on what your needs are, what your reportings or analytics needs are, you can create more than one data set from the same data store. And then these data sets can be used by your consumer for reporting, dashboarding, or analytics. Your data in the data store, in the data set, and I think data store as well, is in a time series format. So there are two types of data set which you can configure. One is called your SQL data set, which is a materialized view from your data store. So it is like you create kind of a SQL query from your data store to create this materialized view. And this SQL data set is primarily used for reporting purposes. Then other one is called container data set, which is primarily used for automated custom analysis. So for instance, you want to bring your data and then you want to use some kind of containerized business logic to do some kind of machine learning or big data analytics on the data, then you go for container data set. So let's talk about these two data set a little bit more in detail. So talking about the first one, SQL data set. Now, SQL data set is used for reporting and analytics purposes. So here you can configure, since it is a materialized view, you can actually configure a SQL query and filter criteria to select a subset of your data store. Again, guys, you can select everything if you want, but generally the purpose is that you define different types of data sets depending on what part of the data you want to perform analytics on. If you want to perform analytics on all the data, then you select all the data. Otherwise, you have a choice to create a small subset of data. And for that, you can create a materialized view using SQL query and filter. Then you also, so this materialized view is not always updated. It is updated based on the schedule. So you can define a schedule, and based on that schedule, the data in the data set will be updated based on the SQL query and filter criteria you have applied. So you can define a schedule for data refresh into data set. Then you can define a data retention period, which is for how long this data will be in the data set. I think default is 90 days if I'm not wrong, but you can choose a different duration if you want. And then you can also select destination for your data set or result, which could be S3 or IoT events. So I will not go to IoT events at this point of time because that's a separate topic in itself, but in the interest of today's discussion, your destination could be S3 bucket where the data is stored, and then your consumer can simply use this data for their reporting purposes. So again, the SQL data set is primarily used for reports and dashboard, but you can also use a SQL data set with a Jupyter Notebook to do some kind of interactive analytics. Okay, having talked about the SQL data set, let's talk about the container data set. And the purpose of the container data set is that you bring your data and then you might want to launch a container-based business logic to automatically process your data, which could be, again, machine learning, big data, anything you want to do. Now, container data set can be made in two ways. You can create a copy of a SQL data set. So you have some existing SQL data set and say, give me a copy of that. I'm going to use that for my container data set. Or you can also link it to an existing SQL data set. So either link or make a copy to an existing SQL data set. And then on top of that, you configure your container. The container, which is running your containerized image, the business logic to process the data, that part you configure. And in order to configure that, you have to provide many things. So for instance, you have to provide the container image, which could be in your ECR, AWS ECR, or other image repository. You have to provide input for the container. So suppose you want to pass say bucket location or file name or some other kind of inputs to the container, you can provide here. You can provide the compute resource on what kind of EC2 machine capacity this container will run. You can provide the compute resource in terms of memory and vCPU. Again, you can define data retention period, and you can also define the result destination, which could be S3 or IoT events. So the container data set is a data set you use when you want to really do an end-to-end automated processing, where you say, when my data comes to data store, I populate my data set, and then I use suppose you have created some kind of containerized business logic using Python or other language of your choice, and you want to deploy that to automatically process your data using your container. And for that, you can go for container-based data set. Okay, so having said that, that was the fundamentals of configuring the AWS IoT Analytics. Today we are going to build a very it looks very lengthy, but it's very small because some parts are automatically configured. Is that we are going to publish an MQTT message to IoT topic, and then we'll use an IoT rule to route it to a channel. Then we'll have a pipeline. We'll simply take this message, put it to data store, and from data store we create a data set, and then we launch a Jupyter Notebook to do some kind of interactive analytics on the data set. So this is what we are going to do today in the workshop. In order to do this workshop, we have a workshop published to our website, aws-dojo.com. I'm going to walk you through the steps in the workshop, and post that you can do this workshop by your own to get a hands-on experience with AWS IoT Analytics. So without wasting any more time, let me jump to the workshop. So here is the workshop where we are going to provide AWS IoT Analytics. So let's start the workshop. And so in the workshop, these are the steps you need to perform in order to complete the workshops. The first step is prerequisite, which is nothing but you need to have an AWS account with administrative access in order to perform the workshop. And if you don't have such account, you might want to use this link to create the account. Then since we are using a Jupyter Notebook for interactive analytics on the data set, so we are going to create a SageMaker role, which will be used by the SageMaker Jupyter Notebook to authorize call to other AWS services. So we go to the AWS Management Console, we go to the IAM Management Console, we say we want to create a new role. This role is for SageMaker, and then I'm just giving, we use the default permission, and we give this a name called Dojo SageMaker role. And it creates a SageMaker role with this Amazon SageMaker full access. but I want to change it, and we simply go and change the permission to the power user access. So we simply give this role power user access just to keep things simple. Okay, so the role is created. Now next step, we go and register the device. So in this case, we go to IoT, and before we register a device, we need to create a policy which device has in order to perform different types of activities. So we go to the IoT, we click on the policies, and we give this policy a nice name called Dojo Device Policy. It can perform all type of IoT action on all the resources. So we'll just keep it simple. Then we go to things section in the AWS IoT to register a device. We say we want to register a thing, and then we give this device a nice name, Dojo Device 1 in this case. And then it will ask you to generate certificates. So though I'm not using certificate in this demo or in this workshop today, but I ask you to create a certificate so that if you want to build your own client and want to do testing with that, you can still do that. Yeah, so we generate certificate for a device. We attach the device to the certificate to the policy, which we just created earlier. And then, yeah, we simply complete the configuration of the device. So my device is now registered. Now it is time to create AWS IoT Analytics, and we are going to use a quick start method. So we can configure each of these channels and data store and data sets individually as well. But just to keep it simple and give you some easy hands-on, we are going to use this quick start method where I simply provide the resource prefix and also the topic on which the message will be published for this IoT Analytics configuration. And we simply say quick create, and what it will do, it's going to create the data store, channel, pipeline, data set, topic, rule, everything it will create for you. And what is important here is that it automatically creates a topic rule which says that if any message comes to this Dojo Analytics topic, then I'm going to route this message to this particular channel. That means I will send that message as raw data to the channel. So yeah, your analytics easily configured. Again, I'm using this simple method to create the whole pipeline, but yeah, feel free to create your individual component. They are pretty self-explanatory in terms of how they can be configured. So next, we configure the SageMaker notebook and attach to data set. So we first go to the your Amazon SageMaker. We say we want to launch a notebook instance, and we simply give this instance a nice name called Dojo Notebook Instance. We give this a nice role name, and this is the same role you created earlier, and we launch the instance. Once our instance has been launched, we go to AWS IoT Analytics. Now we want to associate this instance with the data set we created in the IoT Analytics. So we go back to AWS IoT Analytics. We go to the notebook. We can see that our notebook is up and running. And you click on this create button over here. It will ask you certain way to configure what template I want to use is a blank template. So there are some predefined templates over here which I want to avoid. I want to go for a blank template, and in blank template it says, okay, tell me what data set this notebook will work with, and you simply link it to this particular data set. So you're linking this Jupyter Notebook to this data set. And once you have done that, actually you're good. Your notebook is ready. It can look into your data set and can do interactive analysis for you. Now it is time to publish some messages to a topic. So now we are going to do the publishing of the message, and for that we are going to use a built-in MQTT tool. So we go to the AWS IoT, click on the test on the left-hand side, which will open an MQTT client. We click on publish to a topic message, and remember the topic where the IoT rule is looking for is Dojo Analytics topic. And so we simply say we want to publish a message to this topic, and this is the format of the message. So I'm temperature, vibration, pressure, something I'm publishing, and then message will get published to the topic, and by virtue of this IoT rule we have configured, this message will be routed to the channel in IoT Analytics. Similarly, in order to create some more messages for like analytics purposes, you might want to copy paste each of these messages and then publish those messages to the topic. So once your message has been published to the topic, you can go to your AWS IoT Analytics, click on the data set, and there if you say, okay, I want to run my data, I want to populate my data set now, since it was like, your data set can be scheduled to refresh data, but in this case since we use a quick start, it does not create any schedule, so you have to manually populate your data set. So what we're doing here is we're clicking on the run now to populate this data set manually from the data store. It will populate the data store, and you can see that this is a time series data, and this is the data which just published using MQTT client. So once this is done, our data set is populated. Now we can analyze this data into Jupyter Notebook. So we go to the Jupyter Notebook, and we simply go to the notebooks, Jupyter Notebook, and say open the notebook. It will open the notebook for you. It asks you that what kernel you want to associate this notebook with, so you can decide the kernel, or kernel will decide a runtime for you. In this case, I'm using Conda MXNet P36. And it will start a notebook instance for you. Now, in a notebook instance, you can configure many things, and a few things are actually automatically created for you. So it automatically creates a Boto client for IoT Analytics, which you run to create a client for IoT Analytics. Now, data, we are reading from data. This is the data set and we are reading data from. And this data set actually behind the scene is stored into S3 bucket. So we need to know the location of the S3 bucket so that we can use Panda type of library or other library to read data from that S3 bucket. So in order to do so, you run this line of code over here, get data set content, which will provide you a signed URL of the S3 bucket where this data set is storing the data. Okay, so you get a data set URL which looks like this. And after that, guys, it's pretty straightforward. So what I'm doing here is importing Panda library and importing matplotlib library. First, I'm using pd.read CSV file and from this to read data from this S3 bucket. And then I'm simply printing the data over here just to show you the data has been populated. Then I'm simply using MATLAB library to actually plot my data. So I'm simply plotting the data, putting your vibration against the pressure in a bar chart. So just to show you how you can perform the analytics. So I'm just demonstrating you that you can perform various types of different interactive analytics in the Jupyter Notebook. So yeah, that's it. I mean, so you can see that how you can ingest your data from your IoT devices, and then data gets published to your channel. Then it goes through the whole pipeline till the data set, and from the data set you can use either reporting tools, or you can use Jupyter Notebook for interactive analytics, or you can use containerized images for big data or machine learning type of processing. And in this case, we use Jupyter Notebook. So that's all. The next step is to go and clean up the resources so that you don't incur any cost post this workshop. So that was all for the workshop, guys. Hope you liked the workshop, and if you like, please click on the like button. Please subscribe to my channel. There are many other similar exercises and workshop which you can use to learn about AWS services. Please do visit to our website and learn about AWS services. If you have any feedback or comment or request for new content, you can provide us in the comment section in the YouTube channel, or you can also click on the contact us tab here and can provide feedback here as well. We always look forward to your feedback for the improvement, for the new content, for any kind of correction we have to make in our content. Okay, so look forward to you, and I promise to come back again in a couple of days time with another video. In the meantime, please stay safe and have a nice day. Bye bye.